I don't know why I'm starting to enjoy this, but I am. I'm starting to look forward to this. If f of x is equal to root x and g of x is equal to root x plus 105, find the sum of integers, all integers a, such that f of a and f of g are both integers. Okay, so they don't have to equal each other. We just need to find all perfect squares such that x and x plus 105 are both perfect squares. So we know, okay, something we know about perfect squares is that if we have perfect square x and perfect square x plus 1 squared, the difference between them is going to be an odd number. It's going to be, this is x squared plus 2x plus 1. So this is x, and then subtract x squared, it's 2x plus 1. This is linear. So when do we know 2x plus 1 is equal to 105? Because this is the smallest possible difference between two squares. This is when x is equal to, subtract 1 we get 104, is equal to 52. So 52 and 53, 52 squared and 50, no, I don't think this is right. Yeah, no. Yes, I think it is. Okay, let me just check. What is 52 squared? That's going to be 4, 200, and 2, 500. It's going to be 2704. What's 53 squared? 9, 300, 2500. It's going to be 2809. Okay, see, that has a difference of 105. So if we put 2704 in for x, 2704, okay, yeah, those are both, okay. So 2704 is our absolute maximum. And then we have to go up from here. So if we put 0 and we get 105, which isn't 1, we need to look at 121, which is 16, so that works. 16 and 121. 16 works. We need to look at 144, which should be, this is 4 squared. This is 52 squared. 144, which is 12 squared. 144, we need 939. No. 169, we need 464, it works. I'm just going to look if there's any pattern. 64 is 8 squared, and that goes to 13 squared. Look at that pattern. Here we're increasing by 4, here we're only increasing by 2. So there's such a large increase here for this small decrease here, and then here, hold on. But 64 works, and then after 169 we get 196. 196, we should do 191, no. 20, no, that was 14. 15 squared is 225. 225 is 120, which is not 1. So here we're increasing the gap size. Yeah, so 120 is not 1. Then after, maybe 200, we just did 169, 196, 225. 16 is 256. 256 is 151. No. 17 squared, I don't know. It's 189. Or sorry, 289. 289 is going to be this for 184 now. I think it's 18 squared, 324, I think. Yeah, it's going to be 324, which is going to be 9, gives us 14, is 119, which is again not 1. So we're just skipping a whole ton right here. Is there an easier way to do this other than going through every single thing up to 52? I don't know. The only real pattern I could see here is that these are all even. They are all multiples of 4. So that's interesting. Oh, squares can only end in certain things, right? We have 1, 4, 9, 6, 16, 25, 36, 49, 64. Whoa, 1, 4, 9, 6, 5, 6, 9, 4. And then 64, 81, 0. Well, look, it goes up and then down. So only possible things it can end with are 1, 0, 0, 1, 4, 5, 6, 9. 0, 1, 4, 5, 6, 9. So the ending will have a difference of 5. So 0 to 5 is 1, plus 5. 1 to 6 is plus 5. This is also plus 5. But, it can't end with 5, 6, or 9, the original square. So, of course, this doesn't work, this doesn't work, this doesn't work, this doesn't work. This one, I don't know why it doesn't work. This one is, let me make sure I did the math right. It should be 219. 200, we get 305. Yeah, 219 is not one. Wait, so why does 16 work? Oh, because 16 plus 5 would go back to 1. 5 plus 5 goes back to 0. Why do they all plus 5 if this works? What the heck? So these all actually do work. I was on to nothing. What else? Oh, let me increase my volume. I realize it's a bit quiet. Can I do that? I don't think so. The heck? Why can't I make myself like louder? Um, um, I don't know. I'll figure that out later. Either way, um, we have a difference of 105. So I'm thinking like maybe odd. Does it have to be odd or something? No, because all these work down here. I mean, what else can I do? Here there's a difference of 6, 1, so 7. Here there's a difference of 5. Here there's a difference of 1. So maybe that means there's going to be a difference of 3. There's only going to be one more difference of 3, because this was a difference of 7. This was a difference of 5. This is a difference of 1. Maybe there's one more odd one. Let me try that. How do I figure that out? We have x squared minus x plus 3 squared minus x squared is equal to 105. So we have x squared plus 6x plus 9 minus x squared. Cross these out. 105 minus 9 is going to be 96, so 6x is equal to 96. 96 is in fact a factor of a multiple of 6. It's going to be 10 plus 6 is equal to 16. So 19 and 16. Guys, I'll be right back. So let's test this out. 19 squared is... I was like actually just right there. If I would have just like brute forced it for just a little bit more. 19 squared is 81, 180, and 100. Those can be 361. 361 we need 6, which is 11. Yeah, 256. Hey, that... Hey! Jesus. So I think these are probably all of our answers. Because... I mean, we only get one. Hey, that actually makes so much sense. For a difference of 0, a difference of 1, 2, and 3, there's only one answer, so there can't be possibly any more answers because we have all the differences. Cool. So adding all these together, 16 plus 64 is is 80. Adding these two together is um, adding these together we have 2960. Adding these two together we have 3040. Let me check. Hey, so I got it correct, and it makes more sense the way they said it, kind of. The reason that I only had odd factors was because it can only be factors of um, 105. So of course 1, 2, 1, 3, 5, 7 are all factors of 105 because 105 is 35 times 3. Um, so yeah, but I got this correct. But they did it a slightly different way, but I still got all the right numbers. Anyways, thank you guys for watching. I'll see you guys tomorrow. Bye.